Alright, the objective today is to describe what the Intel manual says about the instruction pointer. I really like the color of that last video, but this one's pretty good too. Well, it says that the instruction pointer, aka EIP, maybe that's our first question. So what does EIP stand for? Remember, E is for extended. That's when Intel went from 16 bits to 32 bits. Just remember, most of this manual first tells us about 32 bits, and then later we'll address 64 bits. But this EIP register contains the offset in the current code segment for the next instruction to be executed. And I scrolled up so you could kind of see my comments here. I said EIP may be a value that is far, far away in memory. Intel says that it is advanced from one instruction boundary to the next in straight line code. So I think I understand what that means, but just in case, I should do some extra research. But the idea of going from one instruction to the other is pretty straightforward. But Intel says it's either that or it is moved ahead or backwards by a number of instructions when executing these types of instructions. So that is like a jump. Both of these are jumps. That's like an algorithm in regular code. And then you have a call, like if you're doing a function call. When the function executes, a lot of times you have a return. So all these instructions are going to utilize this EIP register. Now, the EIP register cannot be accessed directly by software. It is controlled implicitly by control transfer instructions. And there's those instructions again. So it's controlled implicitly. So whatever the value of that is, this is what determines that value. And also, interrupts can determine the value and exceptions. The only way to read the EIP register is to execute a call instruction and then read the value of the return instruction pointer. So that sounds like some real reverse engineering kind of thing. And, by the way, you're doing that from the procedure stack. The EIP register can be loaded indirectly by modifying the value of a return instruction pointer on the procedure stack and executing a return instruction that is right there. And it's cool, it says C section 6242, that is return instruction pointers. I'm wondering if this relates to the whole return-oriented programming, which is an interesting way hackers do some of the things they do without a remote code execution. They use the code that's already there to do the thing that they're trying to do. Now they say all IA32 processors prefetch instructions, and this is because of instruction prefetching, an instruction address read from the bus during an instruction load does not match the value of the EIP register, even though different processor generations use different prefetching mechanisms. The function of the EIP register to direct program flow remains fully compatible with all software written to run the IA32 processors. And I'll end the video here because instruction pointer in 64-bit mode is really easy. It's just RIP instead of EIP. So with that, thank you for watching. Next time we'll talk about operand size and address size attributes.